Welcome back. Problem 7-39. So statement is a beam is constructed from three boards bolted together as shown. Determine the shear force developed in each bolt if bolts are spaced 250 millimeter apart and applied shear is 35 kilonewton. So you can see these are the boards, three boards, 1, 2 and 3. They are bolted together with a distance between these bolts are 250 millimeter to form a beam, and applied shear is V, which is 35 kilonewton. So what we have to find is the shear force developed in each bolt, which is horizontal shear force. So let's start with the solution. So we know that shear flow, which is equal to horizontal shear force per unit length. Clear? So we will find this Q. We also know that Q is equal to V into Q divided by I. So first we will find this horizontal Q, small q, which is shear flow. So for that we will find this I, which is the section property, and that is moment of inertia about the neutral axis. But we do not know where the neutral axis will lie because the beam is not symmetrical about a horizontal axis at the mid. So first we will find the location of neutral axis of this beam. So we know that y dash, which is the location of neutral axis passing through centroid, is equal to y dash into y dash bar into a divided by sum of area. So what if we take this member as 1 and this member as 2? So we can write it like y1 dash bar into a1 plus y2 dash bar into a2. But there are two members of 1, so we will write 2 multiplied by this divided by 2 times of area a1 plus a2. So let's find that. Now first member is this one. So if you take this upper surface as a reference line, so I will highlight it, we will take this as a reference line. So you can see the first member is this one, so its area will be equal to 25 millimeter by this height, which is 250 millimeter. So we will convert them into meter. So area will be equal to 2 times a1 will be equal to 0.025 multiplied by 0.25. And what will be y1 dash? So y1 dash will be its distance from top till mid of this first section. So this will be your y1 dash bar, and that is 250 divided by 2, which is equal to 125. So 125 in meter will be 0.125 millimeter. I will also write it is equal to 125 millimeter. So 0.125 plus, now this is the second member. So its area is 25 millimeter and its height is, you can see this height is 350 millimeter till this. So I will write in meter, it is 25 is 0.025, clear, and height is 0.350. And what will be y2 dash? So I will choose another color. Y2 dash is distance from the reference line till the mid of this section. So let this is the mid of the section, clear. So this is your y2 dash. Now this y2 dash is equal to, you can see the half of 350 is 175. So it will be till this point 175 plus this 100, plus this 100 is 275. So 275 millimeter, and that is 275. Okay, meter. So I will write it 0.275 divide by 2 times area A1. So 2 times A1 was 0.025 multiplied by 0.25 plus the A2 which is 0.350 into 0.025. So when you calculate it, you will get y bar will be equal to 0.18676 meter, or that is 186.76 millimeter. That is distance from neutral axis, distance from top till neutral axis. So this is your top, and it will lie somewhere. Let it lie somewhere here. Clear? So this is your y dash. I will write over here y dash is equal to 0.186 in term of meter 76 meter. Now we will find I. So we know that it is not symmetrical about neutral axis. So by using parallel axis theorem, I will find this. So for first it will be 1 over 12, and we have two members of 1, so 2 multiplied by 1 over 12. Breadth is 25 millimeter, which is 0.025, and height is 250 millimeter, which is 0.250 whole cube, plus area. So area is 0.025 into 0.250. And what is d square? So d square is distance from neutral axis till the mid of first section. So you can see this is the mid of first section and this is neutral axis. So this is your d1. So d1 will be equal to y dash. d1 will be equal to y dash minus y1 dash bar. So y dash is 0.18676 minus y1 dash is 0.125 whole square. Clear? Plus, I will close the bracket over here, plus 1 over 12. Breadth is 25 millimeter, which is 0.025, and height is 350, which is 0.350 whole cube, plus area, which is 0.025, and height is 0.350 into d squared. Now what is d? D is distance from neutral axis. This is your neutral axis. Clear? Till the centroid of second, so till the central line of the second. So this is your d2. This distance is your d2, which is equal to y2 dash minus y dash. So I will write the value d2. y2 dash is actually 0.275 minus y dash is 0.1867 whole square. So again, when you solve this, you will get I will be equal to 0.2702 into 10 raised to power minus 3 cubic meter power 4. Okay. Now we will find Q as well. Q, what will be the Q for shaded area? So you can see this is your neutral axis, and here the bolts, here you will be having a shear flow there. So we will take this shaded area. So this shaded area is 0.025 into height, which is 0.250. And what will be the y dash? So y dash will be distance from neutral axis till the mid of the first section. So this is the mid of first section and this is neutral, which is d1. So d1 is y dash minus y1 dash. So I will write q is equal to a into y dash. So a is 0.025 multiplied by height is 0.250, and y dash is d. So y dash is 0.1867 minus y1 is 0.125. So when you solve this, you will get Q is equal to 0.386 into 10 raised to the power minus 3 cubic meter. Now if you look at, so here, so we have V, we have Q, and we have I. So this is V, this is Q, and this is I. So all the values are given. V is actually 35 kilonewton. So what we will do is that we will find this shear flow, which is equal to V into Q divided by I. So V is 35 kilonewton. So 35 into 10 raised to the power 3. Q is 0.386 into 10 raised to the power minus 3 divided by I, which is 0.270236 into 10 raised to the power minus 3. So when you solve this, you will get 49994,997 Newton per meter, or you can say that it is 49.997 kilonewton per meter. Now you have this shear flow. So what we will do is that we know that shear flow is equal to horizontal shear force per unit length. So Q is 49.997 kilonewton. We need FH, and S is distance, which is 250 millimeter. So you can see S is 250 millimeter. So in term of meter, it is 0.25. So from here you will get FH is equal to 0.25 times 49.997, and that is equal to 12.5 kilonewton. So horizontal shear force or shear force developed in each bolt is 12.5 kilonewton. And this was all about this problem 7-39. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe the channel and press the bell icon so that you can get notification about any latest video which I post. If you have any question, you can ask me in comment section. Also provide me your valuable feedbacks on my video as well. Thank you for watching.